Hello everyone, and welcome to the Think Inc. podcast. I'm Susie, owner and director of Think Inc. At Think Inc., we elevate ideas through live events, and here is a showcase of our online live event series, Outside the Box. Today's show is with Professor Anil Seth. Anil is a British professor of cognitive and computational neuroscience at the University of Sussex. He is co-director of the Sackler Centre for Consciousness Science and the editor of Neuroscience of Consciousness. Anil has published over 100 scientific papers and book chapters and is the editor-in-chief of the journal Neuroscience of Consciousness. He is a regular contributor to The New Scientist, The Guardian, and the BBC, and writes the blog for Neurobanter. Anil and his topic are just unreal, and this was really one of my favourite shows. So here he is, Professor Anil Seth.
This evening's story starts with two philosophers, Ludwig Wittgenstein, the famous German philosopher, and Elizabeth Anscombe, who was at various times his student, his biographer, his editor, and his colleague. Now, one day, Wittgenstein and Anscombe were walking in a garden after breakfast. This is a story, I think it's true. And they were discussing various things, and Wittgenstein just threw this question at Anscombe. He said, they were discussing the transformation between the Ptolemaic model of the universe, which had the Earth at the center, and the Copernican model, which had the sun at the center, the heliocentric model. And Wittgenstein asked Anscombe, he said, why did people say it was more logical to think that the sun turns around the Earth than the Earth rotating on its own axis? And Anscombe thinks about it for a minute and then says, well, I think because it seems as if the sun turns around the Earth. And then Wittgenstein probably glares at her and replies after a second. He says, good, but how would it have been if it seemed as if the Earth rotated around its own axis? Which is exactly the kind of conversation you want to have just after breakfast, isn't it? Now, in one sense, Wittgenstein was getting across the idea, very common in science, that how things seem is not necessarily how they are. Now, it may seem as if the sun rotates around the Earth, but of course, it is in fact the Earth that rotates around the sun, and of course, the solar system is rotating around the center of the galaxy and all sorts of other stuff. But he's also saying something more significant, I think, which is that even when we realize how things are, that the Earth rotates around the sun, in some ways, in many ways, things may still seem the same way they always did. Even when you know this, the sun still, in some ways, seems to rise in the east and set in the west, the same as always. So when we understand how things are, things both seem the same and they seem different. Now, I hope that's got you thinking, because what I want to do this evening is tell a similar story about how we perceive the world and the self, and ultimately, how this applies to the mystery of conscious experience. Here's the how things seem version when it comes to perception and consciousness. So there's this world out there full of objects and people and places with colors and shapes and smells and all sorts of other features. This world is channeled to ourself through the senses to form, through some processing inside our brains, maybe a perceptual window back out onto this external reality. This is how things seem. It's as if we read out sensory signals from the world to form perceptions of that world, as if our senses are transparent windows from a subjective, immaterial self onto an objective, material reality. But how things seem is not how they are. Now, let's start with perceptions of the world and with vision. Now, our eyes indeed open our brains to the visual world, but the photoreceptors in our retinas are only sensitive to this tiny slice of the electromagnetic spectrum, the so-called visible wavelengths. And this thin slice of reality is where we live. And even within this thin slice, our conscious perceptions can depart very dramatically from what's out there. The core idea that I want to communicate to you today that explains this, and I think conscious experience in general, is the idea that your brain is a prediction machine, that what you see, what you hear, what you feel, what you smell, and nothing more and nothing less than the brain's best guesses about the causes of its sensory inputs. Let me unpack this idea a bit. Imagine being a brain There you are, you're stuck inside a bony skull trying to figure out what's out there in the world. Now, there's no light inside the skull, there's no sound either. All you have to go on is a brain, are streams of electrical signals which are only indirectly related to things in the world, whatever they may be. I mean, these signals don't come with labels. I'm from a cat, or I'm from a beer. They don't even come as being labeled as being from the eyes or the ears or the heart. Perception, therefore, has to be this process of informed guesswork in which ambiguous sensory signals are combined with our expectations or beliefs about the way the world is to form the brain's best guesses of the causes of these signals. The brain does not hear sound. The brain doesn't hear or see light. Of course, it doesn't hear light, but the brain doesn't see light either. What we perceive is the brain's best guess of what's out there. Thinking about perception in this way just dramatically changes the intuitions that we might have about how perception works, and indeed changes how scientists have often thought about perception. Now, the intuitive how things seem view is that the brain processes sensory information in this bottom-up or feed-forward direction. This is a map of the visual system of the monkey. And on this view, sensory information enters through the eyes and then progresses deeper into the brain, with each stage bringing increasingly sophisticated processing. Early stages deal with simple features like luminance and edges, while higher or deeper stages deal with more complex features like faces. Now, this view maps neatly onto how things seem. Sensory data carries information about an external world into the brain, where it's read out to form perceptions. Now, the prediction machine view is very different. Instead of perception depending mainly on signals coming into the brain from the sensory organs, it depends just as much, if not more, on perceptual predictions flowing in the opposite direction. So we don't just passively perceive our worlds, we actively generate them. Let me flesh out this picture just a little bit more to give you a sense of how predictive perception of this kind actually plays out in the circuits of the brain, or at least how we think it might play out. Perception is implemented simply by the brain trying to minimize prediction errors everywhere and all the time, so that it's calibrating its perceptual best guesses, its predictions, against the world through just using prediction errors to figure out how on track its predictions are. So perception here isn't about reading out sensory information. It's this process of calibration of the brain's best guesses against an unknown and ultimately an unknowable world. And for those interested in more of the details, this process of prediction error minimization, what it amounts to is an approximation to a mathematical technique called Bayesian inference. And so what the brain is doing in this sense is approximate Bayesian inference on the causes of sensory signals. So the predictive brain is also a Bayesian brain. Now, one immediate implication of all this is that what we hear, what we see, what we smell are all deeply shaped by the brain's expectations, by its predictions. And we all know this in some way. Now, if you walk out on a misty morning and you're expecting to meet a friend on the corner, and you really see that person until you get closer and you realize you've been waving at a stranger. And you really saw, you thought you were seeing somebody else. So colloquially, we're all familiar with this kind of thing, but it holds up in the lab too. This is a simple study just to give you an idea of the kind of work we can do, or we used to be able to do in the lab to put all this on a firmer footing. Here we use a simple method called continuous flash suppression. What we do is we show an image of either a house or a face to one eye and a changing pattern of colored shapes to the other eye. And the contrast of the image gradually grows while the contrast of the colored shapes gradually fades. And the images are merged through a stereoscope so that when you look at the combined image, what you see initially are just the colored shapes. And then at some point, the image, the house or the face, breaks through into your conscious perception. What we did was we led people to expect to see either houses or faces, and we then measured how quickly the suppressed image broke through into consciousness. And what we found over a number of studies is that we see faces more quickly and more accurately when that is what we're expecting to see. And the same goes for houses. So altogether, in these studies for sure, what we see, what we expect to see, not what violates our expectations. And with that in mind, here's one takeaway already. Now, we're used to saying, I'll believe it when I see it. But perhaps we should be saying something else. Perhaps we should be saying, I'll see it when I believe it. Now, these beliefs or expectations, this is important, they're not typically or necessarily beliefs that we're conscious of having. They might be, but they might not be. But they're also beliefs that can operate at many different levels, from implicit beliefs about shadows that are encoded into the circuitry of the visual cortex, to implicit beliefs arising from our social, our cultural, and even our political environments. If you believe particular things, you will perceive particular things. Now, this idea of predictive perception can also help us understand what happens in unusual situations when some people experience things that others don't, what we would typically call a hallucination. And the basic idea here is that hallucinations happen when people's perceptual predictions are too strong, overwhelming the sensory data so that we see what we expect to see, even more so than normal. Let's think about this for a moment. If hallucinations are a kind of uncontrolled perception, well, then normal perception, right here and right now, is also a kind of hallucination, but a controlled hallucination, in which the brain's predictions are continually reined in by sensory signals coming from the world. In fact, you could say that we're hallucinating all the time. It's just that whenever we agree about our hallucinations, that's what we call reality. But I just want to be clear about one thing here, that I'm not saying things don't exist. Like, things exist. Buses, cars, tables, chairs exist. It's not that everything is in the mind. What is constructed is how these things appear in your conscious experience. And that's kind of an important distinction to make. If you go and stand in front of a bus, it will still hit you, and that will not be good. So that's what I want to say about perception of the world. What I want to do now is tell you that the experience of being a self, the specific experience of being me or being you, is also a kind of controlled hallucination. And this seems a bit odd, right? Because visual illusions can deceive my eyes, but how could I be deceived about what it is to be me? And for most of us, the experience of being a person is so familiar, so unified, and so continuous that it's hard not to take it for granted. But there are, in fact, very many different ways we can experience being a self. Being a body and of having a particular body, this object that is my body. There's the experience of perceiving the world from a first-person point of view, perspectival self. There's the experience of intending to do something and of being the cause of actions. This is what we typically refer to as something like free will. And then there's the experience of being a continuous person over time, built from a rich set of memories. And finally, there's the idea of the social self. This is the idea that what it means to be me is partly refracted through the minds of others. I perceive myself in part because of how I perceive other people perceiving me. You see what I mean? It gets a bit circular, but there's an element in which our selfhood is embedded in social networks like this. Now, I'm going to focus just on the bodily self and how we experience what is and what is not our body. Because for most of us, whether we like it or not, this experience of the embodied self is a deeply important aspect of who and what we are. And the question is, how does the brain decide which parts of the universe are and aren't part of the body? And just the same principles apply. The brain makes its best guess based on prior expectations and sensory data about what is and what is not part of its body. At least that's what I think. And here's what's often used as a classic illustration of this, the rubber hand illusion. In the rubber hand illusion, a person's real hand is hidden from sight and a fake rubber hand is placed in front of them. Then the real hand and the rubber hand are simultaneously stroked with a brush while the person in blue, focuses their attention on the fake hand. And after a while, for most people, though not all, the fake hand begins in some way to feel as if it's part of the body. There's a strange sense of partial ownership over this rubber hand. And the usual story about this is that the congruence between seeing touch and feeling touch on an object that looks like a hand and is roughly where a hand should be is enough evidence for the brain to make a best guess that the fake hand is in fact part of the body. Now, I want to take a brief diversion here because since I started talking about the rubber hand illusion some years ago, the story's changed a bit. And in a recent experiment led by my colleague at Sussex, Peter Lush, we've been finding that the degree to which people experience the rubber hand illusion depends very strongly on how hypnotically suggestible they are. Now, hypnosis is not, it's a real phenomenon. It exists. It's a stable trait among people. It's not just stage trickery. It measures how suggestible people are to having particular experiences in particular contexts. And we tested this idea in what is still probably the world's largest rubber hand illusion study, in which we ran nearly 400 people on the rubber hand illusion and also measured how suggestible every one of them was. And it turned out that the more suggestible you are, the more susceptible you are to the illusion. And the idea here is that the context of the rubber hand illusion, like being in the experimental setup, having this fake hand placed in front of you, all of that acts as an implicit suggestion about what you should experience in that situation. And this context affects people differently according to their suggestibility, so that they experience the illusion to different degrees. Now, for our purposes, this still plays into the same story that I'm telling, that this experience of body ownership is a construction based on top-down predictions and bottom-up sensory data, because we can think here of this implicit suggestion as a sort of top-down expectation, but in this case, one that you're not aware of having. So the uncanny experience of this rubber hand illusion is partly dependent on these top-down expectations from the context, but also on the bottom-up sensory data too. And we're currently trying to do experiments to figure out what the balance is. But there are plenty of other demonstrations, especially from neurology clinics, of people who have very strange altered experiences of their body. For instance, people who no longer experience their hand as being there. It's kind of the opposite of a rubber hand illusion. They'll have something called somatoparaphrenia. I'll tend to think that a limb, an arm or a leg, actually belongs to somebody else, maybe my doctor or my brother or somebody like that. And of course, that tells us immediately that the experience of body ownership is not something we can take for granted. Now, for my money, even more powerful than the rubber hand illusion is something called the body swap illusion. And here, by having two people wear virtual reality headsets with cameras attached, you can do something very strange. They wear the headsets, have them face each other, and then you swap the feed so that each person sees themselves from the other person's point of view. Then what happens is you get them to shake hands. And again, this combination of multisensory information leads to something very strange, which is that you feel that you're seeing yourself from the perspective of another. You're shaking your hands with yourself from somebody else's body. Now, this is kind of like an out-of-body experience of some sort. And I think there's an important lesson here, which is that when people, as they have done throughout history, report things like out-of-body experiences, maybe during traumatic or spiritual episodes, we should take very seriously that they have the experiences they say they have. But we should remain skeptical about what they might conclude from these experiences. Having an out-of-body experience doesn't mean that your consciousness or your soul has literally left your body. It just means that your brain has made an unusual best guess about where your first-person perspective is located. How things seem is not how they are. Now, as we move towards the end, thinking more deeply about the body, experiences of embodiment aren't just about body ownership and first-person perspective. There is also this deeper, perhaps more difficult to grasp because it's always there, experience of simply being a body, being a living flesh and blood organism with all its moods, its emotions, and this bedrock sense of simply existing. So this experience of just, being alive without shape or without form, this feeling of being, to put it very vaguely. And this idea, this experience of being a body, brings us to interoception. We normally think about sensation and perception in terms of the 5 classical senses, detecting signals from the outside world. But in fact, a large part of our neuronal real estate is dedicated to perceiving the body from within. This is called interoception, perception based on sensory signals coming from deep inside the body, telling the brain about things like blood pressure, how the heart is doing, how the gut is doing, and so on. Interoception is rather overlooked in neuroscience, but it's critically important because perception and regulation of the internal state of the body, well, that's what keeps us alive. How does the brain do interoception? Well, again, the idea is it works just the same as all other forms of perception, through brain-based best guessing, through perceptual inference. And just as the brain has no direct access to external causes of sensory signals from the world, from things like tables and chairs and whatnot, it also has no direct access to the internal causes of interoceptive signals either. From the brain's perspective, a table over there and a heart in here are both part of the environment. Their nature and condition both have to be inferred. So we can think of the same process of best guessing, but now applied to interoception, to this dance between prediction and prediction error now unfolds purely within the body. So the brain's predictions are about the causes of interoceptive signals, and these predictions are continually formed and reformed by a minimization of prediction error, but in this case it's interoceptive prediction error. If visual best guessing leads to, let's say, perception of a table or of a chair or of a bus, well, what happens with interoceptive best guessing? On my view and the view of many others, what happens are emotions and moods. Emotions and moods are the brain's best guesses of the most likely causes of interoceptive signals. They're the brain's readout of how well the body is doing at staying alive. Now, in a way, this is just a modern version of some very old ideas about emotion that trace back to William James and Carl Langer in the 19th century. And they said in various ways that emotions are perceptions of changes in bodily states. They're not reactions to the world, first and foremost, they're perceptions of changes in the bodily state. But this raises an interesting point, which is that emotions have a very different character to perceptions of the world around us. When we perceive the world around us, we perceive objects and the spaces between them. There's a kind of spatial organization to our perception of the world. That's not true for perception of the body from within. I don't perceive it in terms of objects. I don't perceive my kidney over here and my spleen slightly above and to the left. Emotions don't have shapes in the way that objects have shapes. I mean, metaphorically they might. The pain might be sharp, but literally they don't. And I think this is because perception of the body from within is not about figuring out what's there. It's about control and regulation. It's about keeping the important physiological quantities like heart rate and blood pressure and so on within certain quite narrow bounds that are compatible with our continued survival. And this is because we can use prediction not only to figure out what's there, but also to control. When we can predict something, we can also control it. And this is why we experience emotions the way we do. They reflect the brain's control-oriented best guesses about the survival prospects of the organism. And this has a striking implication. Because if you ask the question, what are brains for? Well, they're not for poetry, philosophy, or even for doing neuroscience, and not even for thinking, really. The most straightforward answer is that brains are for staying alive. The reason evolution endowed any creature with a brain is to ensure that the creature has a better chance of surviving and reproducing. And to me, this means that the way we experience being a self, and indeed all of our perceptions, are intimately tied to our nature as physiological machines, as beast machines, I like to say. And these machines that care about their own persistence over time. Prediction machine brains evolved, develop in each of us, and operate from moment to moment in order to regulate and maintain the condition of being alive. And there's kind of a historical inversion here. If you go back to René Descartes in the 17th century, he used to say that humans were special because we were more than living machines, more than mere beast machines. We had rational minds that other animals lacked. And I think the opposite. I think that we perceive the self and the world because of and not in spite of our beast machine nature. So let me summarize where we've come. What we consciously see depends on the brain's best guesses about the causes of sensory signals. This applies equally to perceptions of the self and of the body, as to perceptions of the world around us. And these self-related predictions depend critically on sensory signals coming from inside the body, on interoceptive signals. Finally, these interoceptive sensory signals, this interoceptive perception, has more to do with control and regulation, with staying alive, than with figuring out what's there. And what's important here is the common thread. All of our conscious experiences, since they all depend on the same principles of prediction, all stem from this basic drive to stay alive. We experience the world and the self with, through, and because of our living and breathing bodies. So here's this what it seems like picture again. The world provides sensory data. It's transmitted to a self to form a perception back onto that world. Now, where we've come has brought us to a rather different view, which is that it's not the self that does the perceiving. The self itself is another perception, another convenient fiction generated by the brain for the purposes of us continuing to stay alive. Our experiences of the world around us and of ourselves within it are both kinds of controlled hallucinations designed by evolution to support us in worlds full of danger and opportunity. And if this is how things really are, then how would they seem, to get us back to Wittgenstein and Anscombe? Well, in some ways, much as they always did, it still seems as if there's a real world out there, that things like colors actually exist as objective properties of an external reality. And it still seems as though myself, what it is to be me, is somehow apart from it, a subjective observer of an objective world. But in other ways, how things seem has changed too, because I can now experience myself and the world through the lens of this new understanding of the brain as a prediction machine. And this does change everything. It changes how we relate to others, because we can understand that we each inhabit our own personalized inner universe. And indeed, we might overestimate the degree to which we experience the world in the same way. We can sometimes be surprised about how differently we see the world, and perhaps this overestimation of how similarly we see things, well, that's the price we pay for communication with each other. It changes how we think about mental illness and psychiatric disorders, because we can now understand these conditions as misperceptions of the world or of the self. And understanding this opens many new opportunities for psychiatry and neurology, because we can get at the mechanisms rather than just treating the symptoms in distressing conditions like depression or schizophrenia. It changes the way we think about other animals. Our individual inner universe is just one way of being conscious, and human consciousness generally is just a tiny region in a vast space of possible selves. And finally, and this gets us to the question that I started with, it changes, or it might change, how we think about artificial intelligence. Now, in the story I've been telling you, consciousness and perception has something intimately bound up with being alive. And of course, in AI, we're used to the idea that as computers get smarter, maybe there'll become a threshold where they also become sentient. Now, finally, it changes how we confront the mystery of consciousness itself. Because now, instead of consciousness being one big scary mystery about how physical stuff, like brains, generates conscious experience, we have instead a collection of smaller mysteries about why conscious experiences are the way they are and not some other way, why redness has the particular character and quality that it does, different from, let's say, the feeling of hunger. And these are the sorts of mysteries we've, of course, been exploring this evening. And when you can solve lots of smaller, more tractable mysteries like this, the idea is that the bigger mystery becomes step by step less mysterious and may eventually dissolve altogether. And there's a final history lesson here too, because in the 20th century, the apparent mystery of life wasn't solved, it was dissolved. People didn't find a spark of life because there was no spark of life there to begin with. Rather, people identified the different properties of living systems, metabolism, reproduction, homeostasis, understood those, and bit by bit, the mystery of life became no longer the big conceptual mystery that it used to be. And I think that the mystery of consciousness stands a good chance of going the same way, that it will dissolve itself through the same process. By understanding how and why we experience the world and the self the way we do, and not by looking for a special source that magics experience from mere mechanism, we will become able to see ourselves more as part of and less apart from the rest of nature. And that, ultimately, that's what a neuroscience of consciousness is all about.
The Q&A with Professor Lila Landowski.
I thought we'd circle back to that original question. We were talking about artificial intelligence. So if we're perceiving the world around us based on these controlled decisions or calculations, does that mean that technology would be able to make those same decisions and become conscious too? We have some comments from the audience here as well, which I can add in as well. Yeah. So we've got David Estevez, he said that I think computers will be able to emulate consciousness at some point, and that's what we'll need to, and that's what we'll end up calling artificial consciousness. But that's somewhat different from being a conscious being. Roz has also said that can anything become conscious if it lacks a nervous system, a brain, and memories? What thoughts do you have about that?
Oh, they're two great comments, actually. I mean, so David picks up on this very important distinction between emulation and what I might call instantiation. And so the idea here is that, computers are incredibly powerful and getting more powerful all the time, and they're certainly getting more intelligent. They're able to do more things. And I think, as you mentioned, Leela, that it's very, very likely that we will increasingly offload complex decision-making to artificial systems, already doing it to some degree in some contexts. But that will become more and more normal. But the question is, will that process does that lead inevitably to these systems becoming actually conscious? And that's what I think David is picking up on. And a lot of people assume that will happen. I just don't think that assumption is safe. If you think about two extremes, like on one extreme, you've got computers that play chess. Now, these computers actually play chess. They're doing it. If they beat you, they beat you. Mm-hmm. And on the other extreme, you've got computers that simulate things like weather systems, but it never gets actually wet and windy inside a weather forecasting computer. So in that case, it's emulating, but it's not instantiating. And so the question is, for consciousness, is a simulation sufficient to give rise to the phenomenon? Is it more like chess, or is it more like the weather? And my intuition is that it's more like the weather, that a simulation is not going to be sufficient to instantiate conscious experience. Because if you were going to assume that it was, that's a very strong assumption about what's sufficient for consciousness. And the idea is, well, information processing is sufficient for consciousness. But I don't actually see a good, clear reason why that should be so.
I think to that end, what would you say if I was to say that if we understand any system well enough, if we can understand the processes that allow it to come into being, that perhaps if we had the technology to understand what it took in our brain to develop consciousness, that it could also be created, just like if we knew what the pieces were in a computer. If we look at these pieces independently, we could say, okay, I don't really know how this hard drive works or this bit, but if we put them together, we can build a computer. Do you think a similar thing could happen with the brain?
Yeah, definitely. And there's a very old tradition about, in fact, it might be necessary for us to understand that we can never really understand something unless we can build it. I mean, Richard Feynman, the physicist, was very famous for saying these sorts of things, right? I think that's true. The question is, what are the component parts? What do they need to be? Is it sufficient to build something out of a computer, or do we have to build it out of neurons? And this gets back to Roz's comment as well, that you said, is anything with a nervous system conscious? And again, it's very, very difficult to say. My intuition is not, but that having a nervous system might be a necessary but not a sufficient condition for consciousness. The real tricky thing will be, I think it's perfectly plausible that we will develop systems that give us the impression of being conscious, and that in itself is going to be quite disruptive for society, because we might just there might just be no good reason that we can have to either ascribe or not ascribe consciousness to such systems. But they will still give us certain feelings that automatically we won't be able to avoid having. And I don't know how many people in the audience have seen one of my favorite films of all time, which is Alex Garland's Ex Machina, which is a beautiful exploration of this idea, this intelligent robot, and played by, what's her name? Alicia Vikander. And the other character is trying to figure out whether the robot is in fact conscious or not, a sort of different version of the famous Turing test for intelligence, but now applied to consciousness. So that's technology. What about animals? So I guess some of the things that we do are clearly primitive reflexes, like our knee jerk, and that's not consciousness. But, if our consciousness is the result of our brain making these
best guesses or predictions in response to the world around us. Well, we see animals that are clearly responding to the world around them and making choices. Bugs even do that. We see ants have these really interesting hierarchies, which we can't explain by reflexes. So does this mean that all creatures are technically conscious, or is consciousness a distinctly human trait?
It's a really deep question, of course, and it's hugely important because it has many implications for how we treat other animals, which we've not historically done a very good job of. It seems to me that there are distinctively human things about human consciousness, but that consciousness in general is much more widespread in the animal world than we might have thought at various times. So consciousness is not, you don't have to be intelligent to be consciousness is not the same thing as intelligence. We humans tend to try and put ourselves at the top of the pile always and say, like, we're smart, we have language, so those things are kind of constitutive of consciousness. The way I've been thinking about it is that consciousness has more to do with these basic predictive mechanisms that sustain life, in which case it's going to be a lot more widespread. And the forms in which consciousness might take for these other creatures is going to be very different too. Mm-hmm. So you talked about animals that can make decisions of various sorts. So I think there's a good example of that, which is, let's say, rats. So I think all mammals are conscious. They have very, very similar brains really to us. But even within mammals, they're going to be very different kinds of consciousness. So you can imagine being sad or disappointed when so just something bad happens and you're sad. You can be then disappointed, which is something bad happened and you're expecting something better. So that already requires a bit more cognitive agility. And then you can have regret, which is, I did A and I got B, which was crap, but I could have done C and got D, which would have been better. And regret, is an emotion we're all I'm certainly very familiar with, and it's you have to be able to entertain counterfactuals to experience regret. And then we humans are, of course, can experience anticipatory regret as well. We can regret things we haven't even done because we know we're going to do them and they're going to turn out bad. Mm-hmm. And there was some wonderful experiments to try and figure out whether rats could experience regret or were merely disappointed. And by looking at the behavior of a rat towards an option not taken when the option it did take turned out to be not very good. So all this is to say that, yes, rats, I'm pretty sure, have conscious experiences, but the degree to which they're similar to humans is a very open question. Like, I don't think rats have a well-developed sense of self, sense of being, I'm Roland the rat. And that should be no surprise, because even human infants don't have a well-developed sense of self until some period of, I don't know, until they're probably 30 years old or something like that. Who knows? or if at all. Sure.
Yeah, you brought up a really interesting point there about regret. Do you think that certain personality traits that we have, like optimism, are kind of a result of the same process, that people who are sad or have a negative affect, are they making the best guess or a prediction that something is going to be bad because it's happened so much to them in the past?
This is super interesting. I mean, one of the practical implications of this way of thinking, sort of independent of whether it provides the best solution to the challenge of consciousness, is the extent to which it can explain the psychological traits, and especially when these verge onto being distressing or things that might be classified as psychiatric disorders. And so when it comes to something like personality types, you can have, for instance, a sort of psychosis-like personality type, and there the idea would be that their perceptual predictions are overwhelming sensory data a bit more frequently than would be for the rest of us. But they can also be, you can also maybe think of personalities. I mean, I'm not too keen on these sort of pop psychological divisions of personality types and trying to reify them in terms of this or that in the brain. But I do think we can explain or say a lot about tendencies to experience things in particular ways as the way in which perceptual predictions might be working. And I know, Leela, that you work a lot on fatigue and things. And fatigue is super interesting because, like, what is it? You feel tired all the time. Well, what does that really mean? And so, one idea here, and I wonder what you think of this, is the idea that if you have something like chronic fatigue, it's your brain is making unusual predictions about how well its physiological regulation is going, that you're basically continually mispredicting your ability to physiologically cope with your environment, and so it provides a bit of a cognitive gloss, if you like, on what fatigue might be, and maybe even a trajectory that explains why this kind of chronic fatigue occasionally turns into things like depression. And which is not to say there's not a physiological, or what you might call organic base for this as well, but it's a complex interaction between your brain's predictions of some underlying organic thing which may have gone away, and some more entrenched predictions that then inhabit the brain about how well it's doing at regulating the body. Does that make sense to you in your work on fatigue?
Well, I think you really hit the nail on the head there, in that I think what's happening when we are fatigued is that we normally have an off button. For example, when we're sick and we have the flu, for example, and we are feeling extremely tired, lethargic, we can't even get out of bed to do the things that we need to do. We are fatigued, fundamentally fatigued. Even our reflexes are slower. So what's happening in this situation is that once we get better, often we still remain with this fatigue symptom. So maybe it's that the switching off or switching back on is failing. That reflex is failing to actually help us be alert in the same way that we should be. And certainly that's something that I'm working on at the moment to try and better understand. I'd like to take a little bit of a tangent here. If a person has lost all of their memory of their past experiences, would they have the same experience of consciousness, or would they have to relearn everything and have the same life experiences to actually be the same person?
Yeah, I think, well, there are some real world examples of this. I mean, well, there's some cinematic ones too. I always go back to cinema as a first step. So I think you may have seen the film Memento, which is a great example of someone who's lost all their memory and tries to reconstruct not only what happened, but who they are too. And this kind of selective but very comprehensive loss of memory, it's pretty rare, but it does happen. And there are these two types of amnesia, actually. There's and they often go together. There's retrograde amnesia, which is you lose memories of the past, but you can still lay down new memories. But perhaps the more distressing one is anterograde amnesia, where you can no longer lay down any new memories. And that's when you sort of see the strange ways in which it's not the same person, but it is the same person. So there's this famous case of a guy called Clive Wearing, who had a brain disease and encephalopathy in the 1980s in the UK. And he emerged from that with one of the most profound anterograde amnesias that's ever been described. Since then, he's never really been able to lay down new memories. I believe he's still alive. So this has been going on for a very long time. His wife, Deborah, described him as living in this permanent present tense. And he would keep a diary. And in his diary, he would always cross out repeated entries that said, "I'm now awake for the first time. I'm now awake for the very first time." And they would all be crossed out. And "I am now alive, awake for the first time ever." So certainly part of his sense of self was obliterated. He had no continuity of his personal identity. But in the moment, he was expressing a personality that was quite continuous with what had gone before. And one of the most moving examples of that was when he used to be a musician and a musicologist and a conductor of a choir. And at one point after his illness, he was taken back to his choir and he conducted them fluently. The music still fell from him as fluently as it always did. But then when he got back to the hospital or wherever he was staying, he had no memory of that happening at all. So we can lose parts of the self while still retaining others. And many of us are familiar with this in less sort of dramatic circumstances with relatives that might have dementia or things like that. There's this gradual chipping away, but everybody will tell you that elements of that person are still very much the same way they always were. And just down to the basics, people with amnesia or dementia typically don't have problems with their sense of first-person perspective or what is their body or of making a voluntary action. So these elements of selfhood can be preserved completely intact, even when we lose things that we may be more used to associating with selfhood, which is like, who am I as a person over time?
Do you think it's because these, these pathways in our brain are so well worn, just like our oldest memories are the last ones to be lost if we have dementia? Do you think this might be why we still are able to retain our sense of identity in those situations?
Could be, yeah. I mean, it certainly seems that experiences of embodiment and volition are, I mean, there are conditions where they get altered or obliterated as well, but it's certainly much rarer than the attrition of memory over time. And I guess that I think you might be onto something there, that see, once you've developed a sense of ownership over actions, really that doesn't have to change much over time. I mean, that's going to be a stable part of your life for as long as you live. But memory accumulation by its nature is a dynamic thing. You always, it doesn't work unless it's open to change. You have to be able to remember new things and forget old things as well. So it may be intrinsically a more fragile aspect of the architecture of self.
What happens if we start hacking it, for example, with psychedelic drugs?
Okay, no idea. I mean, it's fascinating that
can we actively shape our perception of the world, I think is what I'm trying to say.
Oh, yeah. I mean, and psychedelic drugs is one way to do that for sure. And there's actually this increasing resurgence of research using psychedelics, because for the longest time, for generations, well, since the 60s, really, it's been pretty much outlawed from scientific and medical research. And fortunately, that's a situation which is now changing, because these are compounds which they have a very specific and selective effect on the nervous system. They tend to activate the serotonin system or subparts of the serotonin system, and they dramatically change experiences of the world and of the self. And so as a window into the brain bases of consciousness, they are hugely informative, and increasing evidence is emerging that they're very effective in psychiatric treatment as well, especially for things like treatment-resistant depression. And you can see why, because very colloquially, a problem with, let's say, something like depression is you get locked into an entrenched vicious circle of perceiving the world and the self to be a particular way that then sets your behavior down tram lines that reinforces those negative perceptions and beliefs. And suddenly having an intervention that reveals to you that the way you perceive the world is a construction, is one way of knocking you out of those tram lines. Now, that's a story. There's no evidence that that's actually the mechanism by which psychedelics actually have their effect, but it opens up a very, very interesting and rich program of research. And it's much more fascinating than the old story about, let's say, SSRIs and depression, which is just say, oh, you haven't got enough serotonin in your brain, so let's top it up. Doesn't really explain very much about depression or why it should work. And indeed, SSRIs in general don't work that well.
Or why it takes them 2 weeks to start working, even though the effects of the drug are immediate. Really interesting in that, when we also think about psychedelic drugs, there's I guess, a blossoming of neuroplasticity immediately following the use of those drugs. So perhaps that's also helping these differences in perception to be explored by the brain, and therefore altering consciousness going forward.
Because I know the other thing you work on is stroke. So does that mean that you can use low doses of psychedelics to enhance plasticity for recovery from stroke?
That is being used.
Tried that?
There's a lot of promise. I think the big exciting area for us at the moment is the utility of things like exercise. So we know that the brain has stem cells, and stem cells make new brain cells. And exercise is one of the most potent stimulators of these new brain cells. And these new brain cells can retain information, can help us learn, and all those sorts of things. So I think for us, that's one of the most exciting things that we can do, that we all have the tools to do in our daily lives. I would like to take a bit of a segue into dreams. So, there's our awake consciousness, and then there's our dream time. So the reason why our dreams are so strange is because we're no longer constrained by the data with which we predict reality. Like there are no walls, we can I guess the input that we're using is not there. That's why when someone says to sleep on a problem that you can't figure out while on a piece of paper, while when you sleep, you can actually often solve these problems because reality is no longer there. You know, 1 minute you can be in Sussex, the other one you can be in Ibiza, and the next dogs can cook and pigs can fly. All these things are possible. So we don't necessarily have awareness in our dreams that these things don't make sense. So are we really conscious when we're asleep in that aspect?
I mean, I think the short answer there is, I mean, dreams are fascinating. They always have been. They're really tricky to study scientifically. When someone's asleep, dreaming, it's very difficult to have them tell you what they're dreaming about because they're asleep. So it's problematic. There's some people who are trying to do this now. Dreams, for me, they're canonical examples of conscious experiences. So the idea that you're not conscious when you're dreaming, to me, doesn't really make sense, because for me, the definition of being conscious is not being able to reflect or make sense of anything. It's just the raw fact that there is experience going on. So when you're under general anesthesia, sure, you're unconscious. That's the point of general anesthesia. There is nothing going on. You know, you're gone and you're back, and you don't even know how long it was that you were gone for. But when you're dreaming, the whole point we call them dreams is because there's something going on. There's something it is like to be dreaming. But it's just a very different phenomenological character. You know, I was getting annoyed this week. I don't generally remember my dreams. Of course, if you remember which is a good thing, because if you remembered your dreams all the time, you would get very confused about what happened in a dream and what happened in reality. It'd be very problematic to continually make these confusions. So don't worry if you don't always remember your dreams. But I do remember a few of them. And in this last week, I kept having these typical anxiety dream for me is almost missing a plane, running through an airport. I'm late. I've got to the wrong gate. I'm missing. And I just think it's really unfair of my brain at the moment to be imposing dreams about missing planes when that is absolutely not an option at the moment. One idea that I quite like, and it's still just an idea, is that this whole story of perceiving the world through these predictions that we impose upon sensory data, well, that requires, technically, that requires some sort of internal model of the causes of the data, so sort of some internal representation of the causal structure of the world. And in artificial intelligence and machine learning, we know that if you have too complex a model, it tends to overfit the data. It doesn't generalize well to new situations. So one idea that's happening in dreams is that the generative models in our brain that underwrite the perceptual predictions that we apply to the world, what's happening is that they're being finessed, they're being pruned. So they get more during the day, we get exposed to more data, the models get more complex, and then by sort of just free running the models in the brain during dreaming, we can reduce the model complexity, and so that they might generalize better the next morning. So I kind of like that, because it's a mechanical explanation of why dreams have this sort of florid phenomenology that they do.
You mentioned anesthesia. So what's the difference between people being under anesthesia or actually being in a coma or unconscious in a vegetative state?
Not that much, which is probably not what you want to hear when you're going in for an operation. But actually, you should want to hear it, because anesthesia is not just going to sleep for a while. I mean, if you were just going to sleep, then you wouldn't stay asleep once operation started. And so you need a more profound state of unconsciousness. And for those people who've had general anesthesia, I've had it a few times, the differences to sleep are just night and day, to use a bad analogy. But when you go to sleep, even if you're not dreaming, you know that a period of time has passed. You're not going to be out by multiple hours. You might be out, if you've got jet lag, you might be out by a few hours, but you've been away and you're now back. But under general anesthesia, there's no perception of the intervening interval. And this doesn't seem to be just a case of amnesia. This is a case of you really not being there during this time. And if you look at the patterns of brain activity under deep general anesthesia, they have a lot more in common with what you see in coma or in the vegetative state. So these are clinical conditions which involve profound loss of consciousness. than sleep. And indeed, a medically induced coma is nothing more than just the continual maintenance of a deep general anesthesia state.
So does that mean, do we really know where it originates in the brain?
All these questions have very long, could talk about for hours. I mean, in some sense, yes, but there are parts of the brain that we know are essential for being conscious. Mm-hmm. But whether these are the places that in which consciousness originates, that's a different question. So there might be, if you turn there are things like on-off switches for any kind of electrical appliance. Just knowing that there's an on-off switch for something doesn't tell you that on-off switch explains the functioning of the device. So there are certain nuclei in our brain stems, small collections of neurons deep in our brains, that if they get damaged or we shut them down for something, you will lose consciousness. But that doesn't mean, to me, is that like an on-off switch, or is that where consciousness is generated? For me, and I think the kind of emerging story is that the sort of necessary substrates for consciousness in the brain is quite widespread. It's quite distributed. It involves patterns of activity that go between the cortex, the surface of the brain, and the thalamus deep within the brain. And now you can intervene in that process in multiple ways. There are multiple pathways to generate unconsciousness. Mm-hmm. But to be conscious, the whole system has to be active in a particular way. And finessing this idea is actually something that's going on with colleagues of mine across the world, really, but especially in Italy, in Milan. Friend and colleague Marcello Massimini, who's been developing these systems that just look at how functionally connected the brain is as a way of measuring how conscious somebody is, independently of what they say, independently of their behavior. And this has massive clinical importance because for something like the vegetative state, this is a state where people are diagnosed as lacking consciousness, even though they go through sleep and wake cycles. But they don't show any voluntary activity. They don't respond to any questions or anything like that. But if you can apply a measure of conscious level directly to brain activity, you can start to see whether any of these conditions may have been misdiagnosed. Mm-hmm. And it turns out that there is some fraction of people diagnosed as unconscious because they show no behavior consistent with consciousness. Yet, if you look inside the brain through these methods, you can see, there's actually signatures of residual consciousness there. And that really makes a difference. That is already making a difference to people's lives.
You mentioned before interception, so the sense from within. And I'd like to put to you a question, so we have predictions about the world from within the body. So how would we then explain anecdotal observations, like when someone has had a heart attack and they've had a heart transplant and people described that they've got a new personality, which is much like the one of the heart donor? How would you explain those cases? Do you think it's wishful thinking, or do you think there might be something from elsewhere in the body that is influencing these behaviors? As a neuroscientist, it's extremely conflicting, but
yeah, it is conflicting. I think in one sense it's very plausible that, and I think it is the case, that the body shapes our experiences and perceptions. So that part of the sense of being a person is depends on the predictions the brain has about how well physiological regulation of the body is going. Change the body, you'll change the self in that story. But whether it seems to me much less likely that fully formed, multi-layered aspects of perceptual predictions that go into something like personality, go along with the heart. No, I don't think I can't see how that would be the case. If that is the case, that would be very difficult to explain on the kind of story that I'm telling. I think those kinds of things go along more with the brain, but not completely with the brain. I think it's really right to emphasize that our experience of emotion, of selfhood, which underwrites a lot of aspects of personality, that does fundamentally depend on interactions between the brain and the body.
Yeah, and I guess it'd also be hard to discount what are the effects of the anesthesia, of being under anesthesia for however many hours to have that transplant surgery, the effects of the stress of that situation. We know that all of these things are going to be changing the brain and that person's personality.
Questions from the audience.
Luella Moore has asked, hi Anil, in terms of the philosophy of consciousness, do you favour a materialistic, dualistic or alternative approach? Maybe you could explain those three different concepts for us as well.
So these approaches, there tend to be like these general frameworks in which we just like think of what would any answer to a problem of consciousness look like. So materialism is quite a common view, at least among scientists now, which is that basically everything, every phenomenon in nature, including consciousness, ultimately can be explained in terms of interactions between physical processes, physical stuff. So there's no sort of other domain that we need to appeal to. So consciousness is a property of, doesn't have to be necessarily neurons, but is a property of material of some sort or another. That's materialism. Dualism is sort of the opposite, and dualism goes to Descartes and back, and that's the idea that there are two separate domains of stuff in the universe. There's matter, material stuff, but there's also thought stuff or immaterial stuff. Descartes called it res extensa, stuff that has spatial extension, and res cogitans, the stuff of thought. And a dualist would say that no materialist explanation could ever explain why consciousness is part of the universe, that you'll never, through any materialist explanation, however sophisticated, explain why there should be consciousness that happens as a result of that. There'll always be something extra. And the need for that something extra then motivates this view of dualism that says, okay, consciousness just is part of the universe, and there is also physical stuff. And then you have the question of, well, how do the two interact? You know, if you've got consciousness is a separate mode of existence, how does it ever interact with physical stuff? Descartes famously said it interacts through the pineal gland deep inside the brain, which is just not true in many ways. Interestingly, most scientists would be materialists, including me, but the real problem about consciousness is that sort of intuitively, most of us are dualists. Most of us still feel that consciousness is not something that can be explained in terms of mechanisms. So we sort of come at it from an intuitively dualist perspective and then try to convince ourselves that a materialist explanation will be sufficient. And my hope that it will be sort of, again, traces back to this analogy with life, that at one time people thought that a materialist explanation of life would never be sufficient for explaining life. So in that case, instead of dualists, you had vitalists who thought that there was some special source, and then you didn't need vitalism has gone away. But dualism and materialism are only two isms among the sort of huge menu of different philosophical positions that you can adopt. There's monism, which is like there's one kind of thing, but it has two aspects, a conscious aspect and a non-conscious aspect. There's panpsychism, which is the idea that consciousness is sort of everywhere to some extent, or maybe not everywhere, but it's sort of fundamentally part of the universe in the same way that mass and energy are part of the universe. That's becoming quite popular again, although I don't buy it at all. I mean, it may be true, but it doesn't really help. You can't do any, doesn't really explain anything. You can't really do any experiments that way. So yeah, no, I'm going with materialism, and let's run with it and see how far we can get.
Fantastic. I have another question here from Emma Gunn. She says, hey Anil, I'm studying movement neuroscience at the moment, and the question was raised that if the brain controls our movements and thoughts, then shouldn't there be something controlling our brain? I'm wondering what your thoughts are on whether there is a controller of our own controller.
What would be controlling that? I would put it back to me then. If you had a controller controlling your brain, what would be controlling the controller that controls your brain? And you get into infinite regress of mini-me's, of little homunculi that are sitting inside the brain, each trying to, eventually and maybe once you peel back all the layers, there's some soul or essence of you. And I don't think it works, but I also don't think it's necessary. So I think the brain is a controller. That's what brains do. They're control systems for the body, as you said in the question. So a mechanism can be a control structure without itself having to be controlled. I think the challenge comes that it feels like we control. It feels like we have some sort of free will over our movements, that we control our movements. So it feels like, in some sense, if I say my brain is controlling my movements, but then it feels like I am because I decide to do that. And this underwrites a lot of this intuitive feeling that we have some sort of immaterial, dualistic self that pulls the strings in the material world. And I think that also is not the right way to look at it. Again, it's a bit like saying, well, I perceive the color of the table to be red or something like that. Doesn't mean the table actually is red, but it means the experience is real. Now, when I experience controlling an action, I have an experience of free will, but it doesn't mean that there's a controller sort of sitting above or apart from my brain that's pulling the strings. It just means my brain is making a voluntary action and I experience it as coming more from within. And it's that experience that I label with something like free will. No, the brain it does its own control. It just does it in ways that we're still trying to figure out.
Next question is from Ssris and I'm sorry if I butchered your name there. How does Anil's model of consciousness account for religious experiences? Do religious people's beliefs influence their prediction engines to keep them in line with their faith?
I don't know whether it would keep them in line with their faith, but I certainly think that the model of perception that I've been talking about today, I sort of mentioned very quickly a couple of times that these predictions that shape our experience can be at many, many different levels. So at very low levels, they can be about like what happens for objects in shade or where light comes from. We have a very ingrained belief in our brains that light generally comes from above because we grew up in worlds where light generally comes from above. But then there are also more high-level, abstract constraints on our predictions that can be cultural, sociological, political, and indeed, I think, also religious. And these will constrain our perceptions and especially our interpretations of these perceptions. So, for instance, I talked a little bit about out-of-body experiences. So people have these sorts of experiences. I think there will be a mechanistic explanation for these experiences in terms of how the brain reaches its perceptual best guess about where the first-person perspective is. And there's quite a lot of support for that. There's some evidence from neurosurgery that you can stimulate a particular part of the brain and you will generate an out-of-body experience just by a gentle electrical tickle in the right part of the brain. But then how you really experience that change in your location of the first-person perspective, that's going to depend on the wider framework in which all your perceptions are shaped. If you strongly believe that your essence of you is separable from the body, then you'll experience the out-of-body experience as sort of evidence for that. But then there are other, I think more just more everyday ways in which things like religion will shape experience too. I mean, I'm half Indian, and I was recently, well, a couple of times, I've been at this thing called the Maha Kumbh Mela, which is this big festival on the Ganges. Happens every year, but every 12 years, it's the biggest gathering of people in history ever. Last time I was there was sort of 30 million people there. It's noisy, huge chaos. But the vast majority of the people there are there with expressing very devout Hindu beliefs about bathing in the Ganges on this particular day, and it's hugely beneficial. And I have colleagues at the University of Allahabad there who've been studying how people experience their environments. And it seems very plausible that, for me, an experience of noisy, huge chaos is going to be experienced very differently by somebody who's bringing a strong religious context to the same environment.
Next question is from Nuruddin Al-Hajiri. If our senses are the mechanisms that our brain uses to make the predictions that form consciousness, how does consciousness change if one's senses are no longer present? So, for example, if they're blind, deaf, or a combination.
A lot of it will depend on at what stage in life you might lose one sense or another. All our senses interact anyway. So the sensory modalities speak to each other all the time. And the brain is capable of adapting to some extent. So if you lose, let's say, your vision earlier, then other parts of the brain or rather the part of the brain that would normally be involved in vision. And you'll notice, Leela, from your work on stroke too. So there's recruitment of other brain areas to take over some of the functions of the lost function. So to some extent, visual cortex might start responding to sound and allow you to maybe in that case hear better or to touch so that you can read Braille in a better way. I think, and Leela, you'll know more about this than me, but the later in life that you lose a sense, the less plasticity there is in the brain to adapt or reuse cortex to adapt to that loss.
I find that particularly fascinating that, before puberty, there's something remarkable about our brain's ability to adapt. There's a condition called Rasmussen's encephalitis, and essentially it's when children have these constant intractable seizures, like almost every minute of the day, and typically the life expectancy is until your teens. You'll die in your teens. And the way to treat that is to literally remove half of the brain. But it's quite remarkable. If you do this before puberty hits, within a month they can talk again, walk again, essentially function in society almost as if it hadn't happened. Of course, there are some changes and some deficits, but it's quite remarkable that, at this stage of our development, we can almost, reorganize our brain completely and take on all these functions that would have otherwise been lost. If you did the same thing in an adult, you would be unable to function as a human as you were ever again. So I think there's a lot of really exciting things that we can do if we could understand what makes these brains so able to adapt and I guess take over these functions and apply that to an adult. Well, then I think we have a lot of answers, particularly for stroke and a lot of the areas that I've researched, like dementia in the past as well. Irving S. says, if evolution were to continue with our brain, can you posit what future developments our consciousness could come to be?
Oh, well, hopefully just like more sensible decisions about how we deal with the world around us. The way I would think about that question is that evolution is continuing anyway. Evolution just continues. It just does its own thing. But the timescales over which biological evolution changes things is rather slow. But there are faster timescale changes that affect the structure of our brains too. I mean, we will develop, and brain development is affected by the culture that we live in, the environments that we live in, and technology is now, of course, advancing very, very rapidly. So, it now feels like I'm having a conversation with Leela, with you, and you're in Tasmania, and I'm in Brighton, and so this already, I think, is affecting certain aspects of my experience of the world. Certain distances collapse, other distances are greater. As we just, so the question I don't think is less about how the brain is going to continue evolving, but how the brain is going to participate in a rapidly evolving technological environment that will change a lot of what we do at a dizzying pace. To me, it's kind of always been astounding that neurobiologically the basic blueprint of the human brain has not changed that much for tens of thousands of years. Yet we've had this explosion, and for a lot of that time, culture was relatively static, as far as we can tell. From artifacts and cave paintings, not much changed. Now things change very, very, very quickly indeed, and the fact that we have brains that are sort of able to cope with this, even if it feels like we're just clinging on sometimes, is quite a remarkable testament to this sort of built-in adaptability of the brain. What I would optimistically like to think is that looking out into the future, the impact of technology is one that's spreading social networks ever more widely. Of course, there is the real threat, and this is happening, that it's not just uniformly spreading. There's division into echo chambers that we're seeing of mutually reinforcing and incompatible beliefs. But I like to be optimistic and think that the more we're able to look out in space and in time, the better we will be able collectively to deal with some of the larger challenges that face our society, with respect to climate change and pandemics and all sorts of things that need a collective response.
Next question is from Eleanor Gamble. She says, Do you have any insights into the impact of meditation in deepening or expanding our conscious experience?
I've dabbled in meditation, but it's not really something that you should dabble in. I don't think but I have been massively interested, and there has been a long tradition of interaction between meditation practitioners and scholars and neuroscience, which has been very, very illuminating. And I've been to a few events which have been sort of combined meditation, neuroscience, retreat things. And it's no doubt to me that meditation has real and often, they're not always, benefits and can alter our experiences in many different ways. And I've talked to, you mentioned, I think at the top of the show, talked a lot to Sam Harris about this. He's combined his meditation experience and neuroscience in lots of interesting ways. One way I think to understand meditation is that, I mean, of course, there are many traditions of meditation, so I'm just being hugely oversimplifying things, just talking about meditation in general. But it often involves a training of attention. And so there's this idea that it's one way. I mean, much in this sense, much like actually just doing neuroscience, or much like maybe psychedelics as well, it gives you a sort of insight into, it opens up a little space between how things seem and how they are. And you sort of notice, you pay attention to your thoughts and your experiences as they go by, rather than getting caught up in them all the time. And that sort of metacognitive reflective space can be very useful for then coming to this recognition about how we just construct our feelings, emotions, and experiences. But it's a very active area of neuroscience to figure out on a first hand. So, what's happening in the brain when people are meditating. And there's been a number of studies looking at both novices who go through meditation courses, so you can track changes over time, and also looking at expert meditators who may have tens of thousands of hours of practice. And I remember a conversation with Mathieu Ricard, who was the Dalai Lama's French translator and a molecular biologist by training, who's been one of the main guinea pigs. He's a monk now. He lives mainly in the Himalaya. But he's often put himself in brain scanners and tried to enter different meditative states. And there was a lovely collaboration between him and a neuroscientist, Tanya Singer. And they basically, by Mathieu Ricard sort of controlling his mental state through meditation, trying to separate out the neural basis of, let's say, empathy from compassion, which I thought was quite interesting. So yeah, there's definitely a lot to be said, and you do see alterations in brain function under deep meditative states. A lot of them having to do with attention, a lot of them having to do with perception of the body too, but it's still kind of early days.
There's been some studies showing that I think it takes 8 weeks for an untrained individual to be able to experience these effects of meditation on their brain functioning. So, for example, part of the brain called the amygdala, which is a bit like our brain's panic button, it's involved in our emotions and our ability to respond to a situation, that actually shrinks a little bit after 8 weeks of meditation, which sounds bad, but it's actually good. It means that we're not going to be as angry and reactive and responsive to certain situations. We have a chance to be a bit more calm and collected and actually take in the information around us. There's a part of the brain called the prefrontal cortex, which is basically, it involves making decisions. So we do a better job of using our decision-making part of the brain, and we're less emotional about those decisions. Just 8 weeks. Next question. This one is from David Estevez. What does he think when the main challenge for a computer to emulate rather than experience consciousness? So is the roadblock more in the science or in the engineering realm of things?
I honestly think it's an open question. My perspective on this is to try to use computers as tools for understanding how brains create conscious experiences. So can we use them to simulate the nature of sorts of experiences we have, much like that video of a psychedelic experience was earlier. The main challenge is really a scientific theoretical one, is we still have no consensus on what would be the minimal sufficient conditions for a non-biological conscious system, to the extent of even knowing whether that that is possible. Of course, we can create an artificial conscious system by having a child. I mean, if we had some sort of technology that was able to, let's say, scan every molecule in your body and then recreate it. This is the in philosophy you'll notice is the teletransportation scenario. That's going to be conscious. It'll be just like you. I mean, that's what I would believe as a materialist anyway, that if you make another thing out of the same stuff, out of the same molecules, neurons and whatever, you'll have created something that's conscious. But it wouldn't be a computer, it wouldn't be a robot, it would just be another you. And the question of whether a computer as we currently know them will be conscious, it really depends on having a good reason to believe that consciousness is a matter of information processing. And people often assume that, but I just tend to remain agnostic about that. I think actually the more both interesting and concerning cases now involve things like neurotechnologies rather than AI. So people, for instance, these days are developing things called cortical organoids. So in biotech labs now, there's an increasing ability to build, to grow artificial organs from stem cells. And this is incredibly useful. You'll notice, Leela, as well, incredibly interesting from a rehabilitation point of view, if you can sort of regenerate things in the lab and plant them back in. And there's been an accelerating development in growing brain-like structures in the lab too. These aren't intelligent, they can't play chess, they don't do anything, but they are made out of neurons and they wire up in interesting networks and start to display coordinated electrical activity. So I would rather, and we wrote a paper about this earlier this year, actually with an Australian colleague of mine, Tim Bain, that a lot of the ethical worry that's currently being focused on the possibility of computers becoming conscious, we should also focus, or probably more focus on the possibility that these brain-like structures that we're growing in Petri dishes might display elements of a very rudimentary awareness. Seems more plausible because they are made out of the same stuff. So you don't have to worry about whether consciousness is dependent on one particular substrate or not.
I guess the challenge is then how do you measure it? If the organoids that we have in the lab don't have a mouth to speak from or eyes to see. So there's that challenge as well. We have time for just one more question. This one is from Phil Dooley. He says, studies show a time lag between when we do something and when we feel that we decided, almost like something else has decided for us. Is this an artifact of this prediction machinery?
Oh, now this is, I wish I could go on about this for ages. I mean, I love this question. And this is the question about free will. And the studies I think Will is referring to is probably are these studies by Benjamin Libet in the 1980s. And these are studies showing that if you do a simple voluntary action, we talked about this already a little bit, like lifting a finger of your own volition. If I record the time of movement of the finger and I record from the brain what's going on, and if I also record the moments that I felt the subjective urge to lift the finger, then what Libet found back in the 1980s was that there was, by averaging over thousands of these events, he found there was a signal of the brain like ramping up to perform this movement before I would report the urge to lift the finger. So it's as if the brain was gearing up to make the movement before, not only before the movement happened, of course, but also before I was aware that I was going to make that movement. And so this experiment has generated heaps and heaps of discussion and controversy, because interpreted in the most sort of simple way, you would say, well, there's no such thing as free will because my brain knew what I was going to do before I did it, or before I knew I was going to do it. But then the question is, well, what kind of free will are you trying to rescue here? It sounds like you're trying to rescue some soul-powered, uncaused cause, magic nonsense kind of free will. That doesn't really help. And so in a way, it's really not surprising that experiences of intending to do things should have prior causes in the brain. just as much as actual actions should have prior causes in the brain. And I actually think the prediction machine view accounts for this very, very well. They're two sides of the same coin. So my brain is formulating self-fulfilling predictions that generate actions, and it's the flip side of those self-fulfilling prediction that generates an action is the perception of an internally generated action that's associated with an experience of free will. It gets a lot more complicated, unfortunately, because these original experiments of Libet actually were confounded in all sorts of ways, because he only measured the times where actions actually happen. He didn't measure all the times where actions don't happen. So that story got more complicated. But at the end of it all, and I was thinking about this a lot, because I haven't actually written much about free will, but I wanted to write a chapter of my new book about it. So I ended up delving quite a lot into it and to try and think about, does this prediction machine view, how far can it go in accounting for this in a satisfying way? And I think it can go as far as you want it to. And the message is consistent, which is that experiences of free will they exist, but they're not what you think they are. They are not the causes of actions. They are perceptions of the causes of actions.
What a fantastic way to wrap up this talk. Anil, thank you so much for bringing us your wit and your intellect to us today. We've been so privileged to be able to hear from you. Thank you again.
Thank you so much for tuning in to this episode of the Think Inc. podcast. For more, head to thinkinc.org for the full showcase of what we have on offer. And if you enjoyed this podcast, please subscribe. Your support allows us to keep doing what we do, and we appreciate each and every one of you. See you next time.